So hello, everyone. I'm Sogand. I'm a system professor in civil engineering and construction engineering and management at Purdue University. So today I'm here to present on behalf of the other co-authors, especially my student Woei-Chyi, who cannot be here. But he prepared everything for me. So I'm going to continue discussing about the human-robot interaction. So my colleague and great friend Polar was just talking about it. So I'm going to just go one step after that one and talk more about the trust. So if we are being struck by the robots or by the mule that he was talking about, then what will happen? So when we are talking about construction environment, we are talking about the crew, different workers that they're gonna work together. So because there are like tasks that we are doing in the construction, usually it cannot be done by one person. So the demanding nature of the construction industry also dictate that we need to have high performance teams. So in order to have high performance teams, the people should trust, they should work alongside each other and to make sure that they can have the work done with the highest performance. But our construction industry is changing. So Polar was talking about robots that we started using in the construction, and it's not new, actually. If you look at the literature, you see that from 20, 30 years ago, we started using different robots in construction. But the question is that we are still need to keep the human in the loop. So we need to make sure that the human can work alongside robots, interact with drones, and also communicate with artificial intelligence. So this is exactly what he was just focusing on. And when we are having the human next to the robots at the job site, so then our teams are not only human teaming, we are also looking into the human robot teaming. And also, when we are talking about human robot, then we need to ensure that the workers can trust robots. And if something happens, they can recalibrate or maintain their trust level. So real-time understanding of the worker trust is very important. So because if we consider that, okay, I'm trusting a robot, actually, I'm the one that I'm doing research in this area, but I always have the concern about how to trust robots. But if we trust the robot, we need to ensure that if something happened, we can maintain it. So I talk about trust. What is trust? So when we are talking about trust, there is an environment we are having a truster and trustee. So it's a very multifaceted concept, and then it can be impacted by how the trustee will behave and interact with the truster. So the people update their trust level during the teaming. It's a normal process for all of us. When we are teaming up with anyone, based on the performance of that person, based on the behavior, so we may change our trust level. So it has a dynamic nature. We cannot say that, okay, we're gonna measure the trust and it will stay like that. When you look at the literature about worker robot trust, you will see that like they use the different measures in order to evaluate the trust level. They look at the self-report, they look at the behavioral concept and their psychophysiological methods. So in summary, trust is multifaceted concept. It's the dynamic, it can change. So then the question that we'll have is how we can get this real-time trust measurement in order to ensure that workers will be safe when they are working alongside robots. So there are different types of the studies in the literature, if you look at it, that you see that they use different types of machine learning models in order to analyze psychophysiological data, such as EEG, brain signals, heart rate, eye tracking, in order to manually extract the features from this data and then translate that one into the trust. So all of these ones mainly looking at the trust as dichotomy, trust, distrust. But trust is the continuum. So we can have trust, we can have untrust, we can have distrust. So, and most of the literature, they mainly looking at the trust in a static setting, like a manufacturing. So, but when we are talking about construction, Puller was talking about it, that it's a dynamic environment. The environment is changing. We have other workers, other machines in the scene. So we are looking at another type of environment. So the literature showed that like in a static environment, using machine learning, they were able to accurately, like 74% accurately predict trust. In summary, so the literature focusing on the static scenario, not the dynamic scenario that we are actually experiencing in construction. And then they restricted to the normal feature extraction, and they are only looking at the dichotomy, so not the continuum and how the trust is changing throughout the collaboration. It doesn't important that if we trust robots at the beginning or at the end, how it's actually changing throughout the interaction is very important. So in construction, we need to focus on the dynamic environment. We need to ensure that how we will extract the features. And also we need to look at the changes. So the prior work that we did, so we developed a predictive model in order to predict the trust changes, increase and decrease using psychophysiological responses. But there we have a concern. Peoples are different. When we are talking about the different workers, that because of the data that we are getting from the human, their age, their gender, their experience with the robots, they might have a different interaction. So we cannot generalize the data or the predictive model for all types of humans. So then the concept of personalizing the models will come into play. So, but previous study, they mainly use the separate models to train for each individual to facilitate more accurate prediction, and it makes sense, right? But the diversity of the workforce that we have, how many models we can actually train in order to take into account that one. And more importantly, when we are talking about the personalizing our models, the concept of the privacy and inefficiency will come into play. So we need to have a trade-off between the accuracy and the efficiency when we are personalizing our models. So we want to ensure that we are not sacrificing the efficiency while getting more accuracy, because we are actually using all these AI in order to enhance accuracy and efficiency, but we should make sure that we have a good balance between them. So this study, the paper that we submitted to the conference, is actually looking at the trust prediction model, and we are mainly focusing on the partial personalization. So we said that like we don't need to do full personalization, we can do partial, and how. Let me just explain about the experimental setting that we have. So we simulated the future construction environment where the workers need to do the bricklaying, work alongside the bricklaying robots, exactly what Paula was talking about. They can lift and drop the blocks, and then we have the flying drones over by, close by, and they are delivering the materials. They are scanning the person to see that if they are behaving safe or unsafe. And we have the AI assistant that actually will provide them with the information from what direction the drone is coming. So they are wearing the HTC Vive Pro Eye that it has the embedded eye tracker. They have the tracker all over their body, synchronize their movement. They are wearing the FNER's cap, looking at their brain activation, and they are wearing the medical wristband that we are getting their like their stress, emotional level, like the EDR, and then their HR. This is an overview about like how the experiment look like. So we want to make sure that they will have the same movement that the workers will have. And then we have like passive haptics over Y, that is actually the handrail that is there. We also simulate the environmental modalities, which means that like the wind and the sound that you will hear when you are working in the construction job site. There are two types of model that they will do, the baseline model and the error model. So in the error model, what will happen? We actually simulate what Paula was talking about. So when the drone will hit another worker, or when the participant being struck by the drone, and how their trust on the system may change. So they will do, and we measure the trust before and after the baseline model, and then after the error module. So we trained the model using the CNN and LSTM in order to extract the information about the trust and see that if the trust is increasing or decreasing. You may think that like during baseline, the trust will increase, and during the error module, it will decrease. So, but it's not true. So it might increase or decrease on any of this one because of the people like changes and then the diversity of the workforce. So we trained the model using like the 1 model, 2 model, 4 model, 8 models, and 16 models to see that like how the accuracy and the efficiency will change when we are doing the partial personalization. This is the data when we are doing, when we develop the generalized model. The generalized model get the accuracy of the 72% almost, which is less than 74 that we got it in the literature. But that one is the static environment, is different than the dynamic environment that we are using. But when we try to use the different type of data, you see that when we have all the data, we can get more F1 score, but with only the head orientation, with the EDR, like the emotional responses and FNERs, the brain activation, we were able to get the 72%. But with only the EDR, we were able to get the 70% accuracy. That is pretty cost effective for us. We don't need to put all those sensors on the person. But what is important for us is that when we look at the normalized scale for the accuracy and efficiency, we got it, the information for our data. If we only train the model for 7 times for the 7 different groups, then we can get the accuracy and the efficiency that is acceptable. So we don't need to get like 16 or more, because more than that one, yes, definitely the accuracy will increase, but the efficiency will go low. So the insights from this like partial model personalization is just talking about like the specific features need to be extracted in order to predict trust in the construction. And then the workers are different, and we should ensure that the groups that we will personalize our model, they are within the same like gender, personality, work experience, self-confidence, and their experience with robotics technology. So we propose the feature-based personalization that it can enhance the generalizability and also scalability of our model. So because as we said, like a general model, it might get like a higher accuracy when we test it, but if you get the model and implement it for another type of workers, then you may not get what you want. And the most important thing is that the method that we are proposing here not only will work for the worker-robot trust, and also can expand the applicability of that one to the other types of the problems that we are addressing in construction industry. So we were able to navigate the balance between the accuracy and efficiency and make sure that we will get the partial model personalization, that we address the inefficiency of the full personalization, but also improve the accuracy for the generalized model. The cost-effective approach, so we don't need to personalize it for all the people, but what I should emphasize here is that we mainly focus on the next generation workforce, that they will be at the job site. Those are students that they have like the work experience. But we believe that if we repeated the experiment for the current workforce, so we can also expand the results and the findings. What important aspect that we didn't look at it is the accuracy privacy trade-off that we need to look at it in future. With that one, thank you so much.